Swayam Prabha. Digital India. Educated India.
Good morning everyone. In the last two modules, we have discussed on incineration and gasification, two important thermal route for the conversion of waste to energy. In this module, we will discuss on pyrolysis, which is another route, that is thermal route for the production of energy from waste and biomass. We have discussed that incineration is mostly used for the conversion of biomass and waste to energy, followed by gasification and then pyrolysis. So, this pyrolysis process is not widely used in commercial scale, but extensive research is going on for the development on this, and so in future we may get commercial scale applications of pyrolysis. In incineration, we used excess amount of oxygen, in gasification we use controlled amount of oxygen, and in pyrolysis we use no oxygen theoretically, but some amount of oxygen may be allowed and some new research is going on. So, pyrolysis in presence of less amount of oxygen. In this module, we will discuss on the definition of pyrolysis, its mechanism, type of pyrolysis, operating conditions and end product distribution, use of pyrolysis products, properties of bio-oil and need of its upgradation, catalytic pyrolysis, pyrolysis reactors and utilization of pyrochar and gases. We will divide the discussion into two parts. In the first part, we will discuss from definition to the catalytic pyrolysis, and in the second part we will discuss on pyrolysis reactors and utilization of pyrochar and gases. Pyrolysis, the word itself gives some idea about it. So, pyro means fire, lysis means cutting. So, this is the process, that is thermal decomposition process, which decomposes carbonaceous material by the application of heat in absence of oxygen. So, if we have some biomass and waste or any carbonaceous feedstock, just simply we will apply heat. In the combustion and in the gasification, we had to put some other medium, that is oxygen for combustion and O2 and H2O in case of gasification, but in this case we do not need these two, only heat, and that heat will give us char, that will give us gas and that will give us bio-oil. This is very simple to explain this phenomena graphically, but in fact this thing, bio-oil production and char and gas productions, is not so very simple process. Number of simultaneous reactions is going on when we apply heat onto the biomass and waste. If we think about a combustion process or a gasification process, it is very easy to explain these things, that C is reacting, elemental carbon of the material is reacting with oxygen and it is converting to CO2. Here we can say C, it is reacting with oxygen and it is producing CO, but here there is no media for conversion, only heat. So, thermal decomposition is going on. Thermal decomposition is going on. So, the thermal decomposition, what is the kinetics, what is the rate and how this is happening, what will be the molecular composition that is not easy to predict. This pyrolysis is also the part of the incineration and gasification. So, this is the first step of the incineration and gasification. When some waste comes in contact with heat, at first the moisture vaporizes and then devolatilization takes place. So, devolatilization takes place. In case of combustion, the volatile first drying, then it is coming to devolatilization, that will give us volatiles and char. These volatiles will contain many compounds, aldehyde, alcohol, acid, many things. So, when we put oxygen, CO2 plus H2O, when we give controlled amount of oxygen, that will give COH2, and then char is also oxidized CO2 in case of oxygen, again this char is converted to CO plus H2 in gasification. These are for gasification, this is for combustion, but in case of pyrolysis nothing happens here. So, these volatiles will be going off from the system, or if we keep it for a longer time, for longer retention time, so that volatiles will further be broken down into smaller compounds, and those smaller compounds will also be combined together and through different chemical reactions and will produce number of products or components. So, here the pyrolysis mechanism is shown in the slide, where the biomass and waste is taken, and heated, then it gives volatiles, char and also gas. So, this gas may be CO, may be CO2 or CH4, but here what is the temperature? 450 to 500 degree centigrade, very small time, say 1 second, less than 1 second. If the materials is heated, then we will get these things. Now, we will increase the time. So, when we will increase the time, say greater than 1 second, so 400 to say 500 degree centigrade. So, these volatiles will further be broken down. So, this will give some gas molecules like similar CO, CO2, CH4, or it will give some other molecules, that is with lower molecular weight. So, this volatile in vapor phase material is further condensed. After condensation, we will get liquid, that is called bio oil, and other part we will get gas. So, this is the mechanistic path for the production of gas, liquid and char. Now, number of reactions are going on, and depending upon the residence time, depending upon the temperature, depending upon the pressure on this reactor, the distributions of these products will be varying. So, this is one batch scale reactor for the pyrolysis of biomass and waste. We will get some important information in this figure. We have one pyrolysis chamber, very small one inside a furnace. So, this furnace will apply heat, we will put some material here and we are putting here, we are heating by coil, we are meeting the material, we have put it and then it is connected. So, when we will raise the temperature, so that vapor will go, char will remain inside, vapor and gas will go, so we will condense it in the condenser. So, we will get the liquid from this and we will get gas from the top by oil. One interesting thing is how the gases will goes, we need to provide some carrier gas, that is basically nitrogen inert. So, a carrier gas we need to supply, that is not necessary in case of other two processes, thermal processes, that is incineration or combustion and gasification. So, this is the characteristics of the pyrolysis process, where we need to provide nitrogen, or we may put some blower here and create very small vacuum, so that the gas generated may go through this and liquid can be produced. Now, the few questions are, what will be the rate of heating, what will be the temperature, what will be the pressure to maintain a certain products, because the product distributions depend upon the temperature, heating rate, pressure. Depending on the basis of this variation of this temperature, heating rate and pressure, number of pyrolysis methods have been developed and identified. So, in some cases we use high pressure, in some cases we use low pressure, but high pressure and low pressure, this does not mean a very high value of the pressure. You see here, the low pressure means pressure less than 75 kilopascal, and if it is greater than this, so there is high pressure. So, pyrolysis process reacts under atmospheric pressure or below atmospheric pressure also for vacuum pyrolysis, and low temperature means less than 400 degree centigrade, and fast means residence time less than 0.1 second, and slow means this is greater than this. So, these are the some characteristics of, or some important parameters which are maintained in pyrolysis reactor. Now, depending upon this, the value of this, the temperature, the heating rate and residence time, we can get different type of pyrolysis, like say carbonization, the primitive one. In this case, very slow heating rate is applied for a longer period and 350 to 500 degree centigrade is maintained. So, by this method we will get charcoal basically. Then the slow pyrolysis came. So, for slow pyrolysis, the heating rate may be medium or may be low. So, temperature is 400 to 600 degree centigrade. So, here the medium heating rate if we give and 5 to 30 minutes of residence time, that will give us char and gases, that will give us char and gases. But if it is say 450 degree centigrade, but low heating rate and then residence time is in hours, then it will give us charcoal, liquid and gases. Now, first pyrolysis uses the temperature of 500 to 650 degree centigrade and high heating rate is used, and residence time is also less, the residence time is only 0.5 to 5 second, and it gives us liquids and gases. The uniqueness of this process with comparison to incineration and gasification is that it can give three products: gas, liquid fuel and char, and desirable, more desirable product is liquid. So, the fast pyrolysis produces liquids in as a major product and getting more interest in recent years. Further development in the this pyrolysis process is flash pyrolysis. In this case temperature is say 400 to 650 degree centigrade, high heating rate 0.1 to 2 second residence time, and it gives liquid and gases. Similarly, ultra pyrolysis, very high temperature around 1000 degree centigrade and very high heating rate and very less residence time less than 0.5 second, it gives us chemicals and gases. So, vacuum pyrolysis, just we were discussing that when there will be no nitrogen, but there will be some adding some blower at this end, some vacuum can be generated. So, when vacuum is generated, so more volatiles will come up into the vapor phase and it will give us more liquids. So, that is why more liquids we get using vacuum pyrolysis. So, 350 to 400 degree centigrade is required. Here temperature requirement is also relatively less with respect to other pyrolysis, and here we get 2 to 30 second of residence time. Medium heating rate is required. The hydrolysis and methanol pyrolysis are two other processes which have been reported recently, and the conditions are provided here. For all these pyrolysis processes, the product distribution varies with increase in temperature. If we increase the temperature, then the product distribution varies. If we go for lower to higher temperature, say 400 to 650 degree centigrade, the bio oil initially increases and this is decreases. After attaining certain value, it decreases. So, around say 450 to 500 degree centigrade, this decreases. Obviously, this is specific to certain biomass, and then biochar decreases with increase in temperature. So, biochar decreases with increase in temperature, and moisture content there is no much change, in moisture content, and gas content increases with increase in temperature. Gas contents increase with increase in temperature. We can explain this phenomena on the basis of the mechanism of pyrolysis. We have seen that there are primary degradation, then further secondary cracking of the volatiles. So, more temperature gives more gases. So, liquid decreases, and more temperature will also produces more gases and liquids. So, char decreases with increase in temperature, and gas increases because secondary reactions are going on the volatiles, so that more smaller molecules of the gases are produced. Now, we will see the process flow sheets of the pyrolyzer unit. So, one pyrolyzer we will put biomass and waste. That biomass and waste must be pre-treated, because this will be able to handle certain biomass only. So, that pre-treatment is required, just like segregations and homogenization etc. So, that pre-treated biomass that has to be used, and we need carrying gas. Nitrogen inert gas normally used. So, this may be fixed bed type or may be fluidized bed type. If fluidized bed type, then we have to add sand here. So, sand will be fluidized and biomass will also be fluidized with the sand, and heat transfer take place and pyrolysis will take place. So, when these vapors will goes up along with the particles, some particles will also go, and then it will enter into some separation unit. So, this separation unit will give us char. This separation unit will give us char. Part of the char can be recycled here. Then this gas is going from this collector unit to cooling unit. So, here the gas is cooled either by direct quenching or indirect cooling. So, here some example is given as direct quenching. So, here we will be spraying. So, gas will be cooled and that will be collected, and from the bottom we will get water that will be having some impurities and treatment is required for this, and from the bottom we will be getting bio oil. The gas which we are getting, that can be sent here for heating purpose. This can be used for heating purpose. Now, char which we are getting in this case and biomass and waste which we are getting here will be having different heating value. The char will be having more heating value than that of biomass or waste or any other feedstocks. So, this is the flow sheet of pyrolysis process. To understand the kinetics of the complex pyrolysis process, people use the help of TGA, TG and DTA data. So, on thermal gravimetric analysis, the data generated like this. So, in this graph the TGA data, it is evident that up to 200 only around 8% mass loss is there, but when the temperature is increased to 300, so 38% mass is remaining, that means it is 62% mass is lost. So, here after 500 degree centigrade only 4.716% mass is remaining. So, after increasing the temperature above 500, no significant loss of mass we achieve here. So, by DT and DTG, DTA and TG, this TG data, it is clear to us that for this particular biomass, that is sugarcane bagasse, we do not need to hit above 500 degree centigrade. Similarly, from this graph we are getting here the rate of change of mass is different with respect to time. So, this is maximum 0.65 mg per minute at this 311 degree centigrade temperature, and here also 446 degree centigrade we are getting 0.17 mg per minute. So, we are getting that 276 to 446, this temperature is more critical or more suitable for the pyrolysis of this biomass. It is these data are used also to determine the kinetics of the reaction and the order of the reaction. I am not going to explain in detail all those procedure, but extensive research is going on to determine the kinetic parameter for different types of biomass and wastes. Now, we will see the application of pyrolysis products. So, say first pyrolysis, say so it will basically give us 3 product. One is gas, bio oil, char. So, this gas will be used here for the heating of this, because this requires heat. So, that heat can be produced from the gas. Now, this char, some char can also be used and burned outside this pyrolysis reactor and can be heated. Other applications of char, there are some other applications of the char, and bio oil can be used into different routes, through different routes. This can be used for the separation of the compounds present in it. It has large number of organic compounds including acids, aldehydes, phenols, ketones, etc. So, those valuable chemicals can be extracted. So, extraction can be done. So, it can give us valuable chemicals. This bio oil can be upgraded. Its quality is not very good. So, directly bio oil may not be used in engines. So, we need to upgrade it. So, by upgradation we can get fuels, we can get chemicals also. We can also use this bio oil for gasification. We can use this for turbine, we can use it for engines, we can use it for boiler and co-firing So, boiler and co-firing will give us heat, engine and turbine will give us electricity. So, gasification, turbine and engine will give us electricity. Gasification will also give us fuel. So, from bio oil we can get different chemicals, different fuels, and it can be used for electricity and heat production. Here we will see some important chemicals which can be produced from the bio oil, that is some resins, fertilizer, flavors, adhesives, acetic acid and industries feedstocks, and some fuels we can get from hydrogen through gasification hydrogen, upgraded hydro deoxygenated fuels. The hydro deoxygenated oxygen present in the bio oil is in higher amount, which is not desirable and reduces the quality of the fuel. That is why this deoxygenation is required, that is called upgradation. So, that fuel can be used, and once the gasification we are using, we can get other FT synthesis also. So, we can get other fuels. There are some properties of the pyrolysis bio oil. We will now discuss some important properties and responsible for these properties. For example, this oil is having some appearance, that is dark red brown to dark green appearance. So, this appearance is because of microcarbon and chemical composition in oil. Another property is its odor. So, distinguishing this distinctive odor and acid smoky smell is available, that is due to the presence of different types of aldehydes and acids. The density of this is more than the fossil oil, and it is given here, and this is because of high moisture and heavy molecular contamination, and viscosity and heating value is also not similar to the transportation fuels. Another important difficulty with it is aging, means with time its viscosity increases, volatility decreases, phase separation takes place. This is because of the presence of different molecules which are generated through the degradation of cellulose and hemicellulose as well as the lignin as mentioned here. Different types of acids, aldehydes, alcohol, sugars, phenols etc. are responsible for this phase separations and other degradations in the quality. This here we see the comparison of some properties between diesel and biodiesel. We see here the moisture content, and oxygen content is very high with respect to diesel, which are not desirable and reduces the quality fuel quality of this, and low pH, that is 2.5, due to the presence of carboxylic acids and acetic and formic acid etc., which are also not desirable. The heating value is also less in this case, and that is due to the presence of high oxygen content. There are some advantages of this process, that is we can use the waste, we can get the liquid product, okay, but it has some disadvantages also. The oxygen containing in the liquid fuel is not desirable, it is not stable for a longer time. So, there are a number of disadvantages as mentioned here. So, to remove this disadvantage, the upgradation of the bio oil is required, and physical methods and chemical methods are used for the upgradation of the bio oil. The physical methods is filtration for char removal, emulsification with hydrocarbons and solvent addition. For the chemicals methods, reaction with alcohols and catalytic deoxygenation. So, the catalytic deoxygenation can be done either by hydrotreating or by application of some other catalytic vapor cracking. So, this hydrotreating is performed at temperature of around 35 degrees centigrade with some catalyst, that is cobalt molybdenum and your nickel molybdenum. So, using this catalyst the hydrotreating is possible. So, another approach is going on, either we produce bio oil and upgrade it. In place of this, the people are trying to use catalyst during the production of the bio oil, that means in the pyrolysis process, and different catalysts have been introduced in the pyrolyzers and the quality have been improved in terms of its reduced acidity, viscosity and oxygen content. So, here some catalysts used for this purpose are mentioned. So, up to this in this module, and we will discuss in the next module about different pyrolysis reactors. Thank you very much for your patience.